going on, guys? Welcome to part 1 of the Trading Cryptocurrency with Python series. The goal is to make this series accessible to beginners in Python, people that have never written a line of code before. It'll all be explained along the way. So let's jump right into it. The first thing we'll need is a connection to the Binance API. So I'll open up a browser here. I'll go to binance.us. I'm in the United States, so I'm using this binance.us. For those of you that are not in the United States, you just go to binance.com. They just have two separate exchanges, one for the United States and one for outside. So I'll go to binance.us. I'm brought to my dashboard here. You can go ahead and create a Binance account if you don't have one already. And then once you're to this dashboard screen, you can come to the top right corner and click API Management. So you see this first field here. It says give the API key a label. This is where you can create your API. You can give it a name. This isn't super important, just so you can remember which API you're connecting to. Click Create. So it'll ask you to go to the email that you signed up with to verify that API. So I'll confirm API creation. And you'll see that API here. So we have two things. We have this API key and the secret key. The secret key will pop up the first time you open the screen. As soon as I leave this page, the secret key will no longer be visible. And if you lose this secret key, you'll have to, you can see here, if you lose this, you'll have to create a new API connection. One other thing I've had issues with when creating this API is some browsers will block this screen. So basically what I had to do, I'm using Brave browser, I just had to turn the shields off while I do this API creation. But basically what we'll want to do so that we can connect to this API later on is we'll want to copy these two things and save them in a Python script. So I'll copy that secret key, and then I will I'm going to use Visual Studio Code to create a Python file. You can use whatever text editor you'd like, but we just need a Python file here, and we'll open folder. I have this this empty folder here. So then I'll do new file, and we'll save this as a Python file. Let's call it Binance Keys. Save that. What we need here is basically two variables. They'll just be string variables to save this API key and the secret key from Binance. So I'll call this first one API key, make that a string, and then we'll have secret key, and make that a string as well. I have that copied, so I'll paste that in. And then I'll grab this API key as well. I'll paste that in. You can save that, and we can close that directory. And that's all we'll need from Binance for now. So now you can, once you have that saved, you can leave this page. So now that we've created that API, we'll actually need to install Python to make a connection to it. So we'll open up a command prompt here and just type Python. And if you don't have Python already installed, this will bring up the Microsoft Store, and you can, then install Python from there. I'm going to install Python 3.9. So now that we have Python installed, we can check to make sure that worked. Type in Python 3. This will bring up, Python 3.9.6, and you can see we are inside Python here. So we can exit that. So now that we have Python installed, we can start with installing some dependencies we'll be using to access Binance. So first we can type pip3 install python-binance. This is Binance, or the Python wrapper on the Binance API. So that'll collect and install a bunch of different dependencies that requires. So that's installed, and we'll also be using pandas. So we'll be pulling data using that Python wrapper on the Binance API, and then we'll also be using pandas once we have that data to install it. So pip3 install pandas. Okay, so we have pandas installed, and lastly we will be using Jupyter Notebook as our development environment. So we'll pip3 install Jupyter. Okay, so now that we have Jupyter installed, we're going to use this cd function. This stands for change directory. And we're going to cd into that folder where we have our Binance keys. So in my case, that is documents, and you can tab to autocomplete this /01 trading series. So you can see I'm inside this directory here with only this Python file with my Binance keys. And I'm going to Python 3-m notebook. And this will open up Jupyter that we just installed. And this is where we'll be doing our development. And so I think Jupyter is a great way to explain things like this. You can run, so we'll create a Python file. I'm just going to show you what Jupyter is all about. So Jupyter is nice because you can run Python code within each of these cells here. And so for example, we'll import pandas into the script, and then hold shift, push enter, and it'll import pandas. And then we have another cell here. So we can print. And you can see this is a very good way. This is why I like using Jupyter for tutorials like this. It's a very good way to just kind of see what's happening piece by piece. So if you'd like, you can follow along in just a normal Python editor, but that's why I'll be using Jupyter for this purpose. So we'll name this first script gather data. And so I've already imported pandas. We'll also import that Binance wrapper, or the client from that Binance wrapper. So it's import Binance.client. Actually, it is from Binance.client. Import client. And so now that we have pandas and our Binance client imported into the script, we're going to actually use this client and connect to the Binance API that we previously created. And so we called that file Binance_keys. And so you see where our Jupyter Notebook here is in the same directory as this Binance keys Python file. And so we'll import that. So we'll say from Binance keys, we'll import, we have two variables in there, API key, and we also have one called secret key. So import those two things. And then to connect to that API, let's just go to the Python Binance documentation, get the exact syntax. So we'll go to this Getting Started tab, and we'll just do copy and paste. So this client function to connect actually takes two parameters. It takes those two keys, and we call this secret key, so we'll paste that in there. Oops. So once we have those two things, I can run that, and you can see we have this client connected to the API we created. So the next thing we want to do is we want to grab some data from the Binance API. So we want to, in order to backtest any trading strategy, we're going to need some data. And so we'll start with, go back to the documentation, and there's a function here called get historical clients. And we'll use this function as a way to query the Binance API and get some historical data. And so you see this function takes symbol, interval, start string. You can also put an end string. It says it's optional. If it's blank, it'll just fetch everything up to now. So we'll just do that. And then these are also optional parameters that we won't be using. So use this get historical clients function. I'll just copy the first three there, first three inputs to that. So we need a symbol, an interval, and a start string. And so if we go back to the docs, this will be like your pair of coins you want to get the price for. So we could just start with, we'll say we want to start with Bitcoin. Let's do BTC. And then our interval is Binance client interval. This will be a constant. So we can go to Binance constants, and you can see the list of different intervals you can input here. So we'll just do the 1 minute interval as the most discrete data we can get. So I'll do interval equals, we'll call the client, and do that client interval 1 minute. And then for our symbol, we need to specify that we want Bitcoin against US dollars. So we'll do Tether, the stable coin for US dollars, which is, so I'll do an F string here, input that coin variable, and then we'll do it against USDT. And so if you haven't seen this F string format here before, basically what this is doing is it's just taking that coin variable and plugging it into this string here. So I can show you. So if we run this, because we can make sure we have the coin initialized, and you can see this will just return BTC USDT. And so I pulled this coin outside just so that we can input different cryptocurrencies if we want to. But we'll stick with Bitcoin for now. And then for the start string, we'll just do, it's currently August 22nd, we'll just do the last week. August 15th, 2021. And we will put that in here as well. And we will just call this clients. Oh, and we gotta call the client every time we need something from Binance API, you gotta call that client. So it'll be client.getHistoricalClients. So now we have the result of that, what we just fetched from the API stored in this client variable. So let's take a look at that. You can see what we have here is a long list of lists, and so each of these inner lists is one data point. But you might wonder, why do we have so many different values here? What are these things? So let's go back to the API and back to that get historical clients function, and we'll see what the result of this function actually is. So they have an example here that specifies all of the different things you're seeing here. So just put this in a string, and so we can use this to reference it. Basically, we have the open time, open price, the high within that interval, the low within that interval, the close price, volume, and a few other things as well. So what we want to do is, instead of having just a list of lists here, we want to actually use pandas to make this into a data frame. And so we'll do pd.dataframe. We imported pandas as pd, so that's why we're doing that pd.dataframe. And you can see the parameters this takes. So we first just need our data. We have that stored in clients. And so you can see this, put this in a tabular way. We still don't have any of this labeled. We don't know what, just by looking at this data frame here, you don't know what any of this really means. So let's give this some column names. I actually have this copied to my clipboard already, just so you don't have to type it all out again. We can basically, run. So using f strings again, we're going to define each of these columns as they're listed, from the results from the API. So we'll run this, and we'll put this above here, and then we'll just set our columns input to this function as calls. And you can see now, instead of just 0, 1, 2 for the column names, we can see we actually have all of our data labeled here. And so putting the coin we want into each of the columns, this will allow us to get different coins as well. So if we have, say, we get Ethereum prices, we can do this all again and add, for example, ETH USD Open or and get the prices for different coins as well. So we can keep adding to this data frame and keep adding different coins, and you can basically grab as much data here as you want. We just did 1 week's worth of Bitcoin data, but for example, you could get the last, as far back as the API goes, you could get the last few years worth of 10 different cryptocurrencies. And so this is a really good way to develop a data set for backtesting any strategy you have. And so now that we've gotten data for one cryptocurrency, let's get it for a couple others as well. So let's call this coin DF, coin data frame. So this is the data output of calling one cryptocurrency from the get historical clients function. And so instead of having just one coin saved here, let's instead call this coins, and we'll make this a list of different coins that we want. So the goal is, if you want to add or remove different cryptocurrencies to coins in your final data set, you can just add them to this list and rerun, and you should be able to get multiple cryptocurrencies. So in this case, let's do Bitcoin, Ethereum, and Litecoin, probably the most common cryptocurrencies out there. But you can see how you can apply this to a large variety of others as well. And so then we're going to do everything that we just did. We're going to do it from the same start date. But instead of just doing it for the first one, let's do it for each coin in coins. And so the way you do this in Python is with a for loop. You can say for coin in coins, and then you can do everything we just did. And so you need to indent this here, and basically everything inside this for loop will happen for each coin inside the list of coins. And so it's going to put, it's going to go through and do what we just did for Bitcoin. It's going to get a data set. It's going to do it for Ethereum, and then it's going to do it for Litecoin. Okay, so copy this, and we can bring this up here just to have it all in one line. So what we're going to do is we're going to call the get historical clients function. We're going to get each of these. We're going to save it to clients and save it to coin df. But we don't want to overwrite this every time. We want to actually store it into one big data frame of all of the coins. So let's call all coins df equals pd.merge coin df and all coins df. And so this is Panda's functionality to merge or join two data frames together. And we're going to say how equals inner. So there are different methods of doing this. Inner join just means everything that's in both data frames put into the new data frame. And this is based on, so you can see the different ways you can do this, but we're going to use inner, and you can see this is how you do this is based on this on parameter here. And we want to do this on the time columns. So if a column has the same open time and the same close time, then we want to join it in these two data frames. So each time point that the API is grabbing from get historical clients will get joined, and you'll have one column for each different coin's price, or different coins high or low, or whichever column. And so we're going to do this for our first column, open time, and then our second column, our second time column, close time. But the thing we need to remember is if this is the first time we're going through this loop, we're not actually going to have this all coins data frame. And so what we want to do is we want to make this a conditional. We'll create this variable merge. So merge equals false. If it's the first time we're going through this, we don't want to merge because we don't have anything to merge it to. It's the first time. So we're going to do if merge equals true, or we can just do if merge. This is asking, does this merge variable equal true? The first time it goes through, it's going to say no, it's equal to false, and it's not going to do this. It's actually going to move on to the else statement. So again, if this is the first time, we don't have anything to merge to, so we're just going to say altcoins data frame equals coin data frame. And so we actually have to, yeah, so we'll get our first, Bitcoin data frame. This will be false, so it'll move on to the else statement, and it'll save it to altcoins.df. Then we'll move on to Ethereum, and we'll get Ethereum prices and data in CoinDF, and then we'll merge that to the Bitcoin DF. But in order to hit this statement here, the first time around, we need to set merge to be true. So now this will go through this entire list, and it'll actually merge all of these coins data together. And so you can do this for an arbitrary list of coins. Right at the beginning, let's just print coin. And this is just so we know which coin we're gathering right now. We can say gathering each coin. We can run this. I didn't close my string there. And you see we're gathering Bitcoin. And then we can watch this and wait for it to gather all of the rest of the coins. When you're gathering really large data sets, I've noticed sometimes the Binance API will try to kick you out after you ask for too many things. So sometimes if you just want to add time.sleep here, maybe you sleep for like 60 seconds after each data call, then the API won't kick you out. You can let this run for a while. Come back to it later, and then if you do call this time library, you'll need to import time up top. But since we're only asking for a week's worth of data, this likely won't take too long, and it won't kick you out for too many asks. And so now that this is done, we can take a look at this altcoins.df as data frame, our final data frame, as a result of that. We can see we have 32 columns. So we have our open time, our close time, and then we have another column for each of those cryptocurrencies that we entered. So to get a better look at that, we can take a look at altcoins.df.columns, and we'll just make this a list. And you can see those are all the different data points we have. In the Binance documentation, this last column, it just says can be ignored. I'm not sure what exactly this is, but it just called it -ignore for each of these. So now that we have all that data put together in one nice clean format, there's a couple last things. One thing we'll have to do is, you can see these times are just, they're currently timestamps instead of, we can change them to a date time format. They're easier to read and easier to work with. So we'll do that first. So we can import, say from datetime, import datetime, can run that, and then for each of these, so we want to use the datetime.fromTimestamp function. So we'll call that, and we'll just do this for the first one just to see how this works. So we'll get this first data point in open time, and then we'll get the first index of that, the 0th index of that, and that is this right here. And the way these timestamps actually work from Binance is they include milliseconds, but the from timestamp function actually doesn't look at that. So this has 3 extra digits on here. So we'll just be dividing this by 1,000 so that it works with the from timestamp functionality of the datetime package. And so we'll enter something like this into the from timestamp function. And then you can see that this timestamp here is actually August 14th, 2021. And so instead of just doing one here, we want to do each of these columns. And so we want to go through each timestamp in this open time and close time column, convert it to a date time, format and then write it back to these columns. So we're going to say all coins data frame open time is equal to, we're going to make this a list, and we're going to use a list comprehension to iterate through this and convert each to date time. So we're going to do date time from timestamp. We're going to call it TS for timestamp, and then we're going to do for TS in this column. So what this does with list comprehension here is it basically condenses what we did, how we wrote this for loop, into a single line. So this is what it's doing inside the for loop, and this is defining the for loop. So for each timestamp in this list of timestamps, in this case the open time column, it's going to convert it to a datetime using the datetime.fromTimestamp function. And then the list on the outside, the brackets on the outside mean this is a list, and it's going to assign that list to all coins data frame, or to this column, open time. And then we can do the same thing for the close time. Let's take that. Then we can run this. And we forgot to divide by 1,000. I mentioned there's milliseconds on each of those timestamps, and the from timestamp function does not look at milliseconds. So now that we've converted both those columns, we can take a look back at our all coins data frame, and you can see that there's timestamps in here, and these are each, we put interval as 1 minute, so you can see we have one data point at each minute for both the open time and the close time is converted as well. And so another thing that we're going to have to modify with this data frame is the Binance API actually returns each price as a string. And so we want to convert each of these prices, or every other data point in here, we want to convert it to a float. And so an easy way to do that in pandas is you can call the name of that column. You can do as type float. And so this will give you that entire column as a float, and you can assign it back to that column. So this will convert the whole column to a float and then overwrite where the column initially was. We don't want to just do this for this Litecoin open column. We want to do this for all the columns. So let's again use for loop, and we'll say for call in all coins df dot columns. So this will iterate through the names of the columns. And then it'll do this same action. So we can replace that column name with call, which will be the name of each column as it iterates through. And then lastly, we don't want to touch the open time or the close time because we already converted those to date times. We don't want to convert those to floats. So we'll say if not call, we'll say time in call. So this will check if this string, time, is within the column name. And so in the case of open time and close time, it will be in the column name, and this last statement here will not get hit. So it'll just pass on it in those cases. But we can run this, and then we can take a look at actually we'll just take a look at all coins df. We'll get this first one here. We'll just make sure that was converted. Do index location 0, and you can see this is now a float. Okay, so we'll delete that out. Some of the other things here for showing examples. And so lastly, what we'll do here is we now have all the data we want in the specified format. We've converted everything to the proper data type, and we have all three cryptocurrencies within this data frame. But just to kind of look and see what this data actually is, make sure it's correct, let's actually plot this data with Plotly. So I'll do Plotly candlesticks And so Plotly has a nice library to actually plot these things. So we'll copy this. Well, first we'll import this graph objects functionality. And we're going to have to install the Plotly module as well. So to call command line commands from within Jupyter, you can actually do this exclamation pip3 install Plotly. So we have Plotly installed here. So I'll delete this out here, and then we can import this graph objects functionality from Plotly. So we can go back to the documentation here, and we can copy this statement. We don't need to write this ourselves. And you can see here, this is using Apple data as an example, but it's calling the open price here, high, low, and close. And we obviously have all that information, so we can just substitute this out. We'll change DF to be all coins DF in all these cases. And then from our column names, don't have that up anymore. So I'll just grab the necessary information from here. And so we can grab, we'll just use Bitcoin for now, but you could do this with any of the cryptocurrencies we have in this data frame. So we'll take this open price and we'll place it there. The high. The low and the close. And our date column is not called date, it is called, we'll just use the open time as the date. Okay, we can run that. And you can see, I think there's another parameter we can use in here. Yeah, so we don't want this range slider, so we can actually zoom in. We'll just copy this whole line. So we can update this figure without the range slider. And then you can see we have candles of all of the data from, remember our start string was August 15th. It went from a little bit before August 15th until the current. So it's currently August 22nd, and you can see this is currently what Bitcoin is doing. And you can zoom in. Plotly is very interactive, so you can zoom in on whatever different portion of the chart you want. If you gather more than a week's worth of data, I wouldn't recommend using Plotly in this way. It's just too much data to put in this window. But so you can slice it, down to like a week and then look at it in that way. But this is good confirmation that the data we have is kind of what we were aiming for. I think that'll wrap it up for this video. In the next parts of the series, I hope to implement some strategies in backtesting. So we'll use this data that we now have and just see what would have happened had we traded over this period of time. Maybe I'll grab some data from like the past couple of years or something, and we'll run some backtests and kind of show you how, maybe have some strategy in mind and how you can implement that into Python code and check what would have happened had I traded on this strategy over time. After we backtest some strategies, then you can actually go ahead and implement it. So we'll learn how to query the Binance API live, get prices, and do exactly, you can actually buy and sell real cryptocurrencies using real money live on the Binance API, all just within this Python script. I hope you enjoyed the video, and we'll see you in part 2.